So, good morning, my dear students. In today's class, we will going to start the module 4. So, in module 4, we have projection of solids. See, once you have understood how to project planes, so with the different geometry, just like a square or a triangle or a hexagon or a pentagon or a circle, the next thing is the three-dimensional object, what we call it as a solid. Basically, a plane is a two-dimensional object. It can have only length and the thickness, means length and the width, whereas the thickness will be considered as a negligible. But in the case of a solid, which is a three-dimensional object, all the three dimensions of the object should be considered, and then when it is being positioned with respect to the reference planes, so we have to write a corresponding. In the sense, the object here is the solid. Okay. So till now we have discussed a point, we have discussed a line, we discussed a plane. So now the most important thing is the solids. When the object is considered as a solid here, or when we say the between the observer and the reference planes, the object is in the form of a solid, which is a three-dimensional body. So when this solid has been positioned and its position has been represented with respect to the reference planes, which is a vertical plane and a horizontal plane, and it can be positioned in an infinite number of positions, infinite number of ways, we can call it as. Okay. So whatever it might be the position, whatever it might be the inclination that the solid has been placed. So you being the observer, you are at an infinite distance, and whatever you see, whatever the image that you will going to be seen, that will be represented on a corresponding plane which is been kept perpendicular to the direction of your visual phase. So that is what we were talking about an orthographic projection here, right? So in the similar way here, when the object is in the form of a three-dimensional body, okay, so you are at an infinite distance and you are observing an object, and its view will going to fall on the vertical plane if you are observing the object from the front, and the same thing if you observe the object from the top, its corresponding view will fall on the horizontal plane. Okay, that is what we call it as the front view and the top view. Okay, so these things we already been discussed, and already you have drawn so many projections for the planes as well as the lines. So therefore, no need for me to explain these things. So now only thing is the object is in the form of a three-dimensional body. Okay. So now you are observing the object, and correspondingly all its projections will going to fall on the reference corresponding plane. So front view will fall on the vertical plane and the top view will fall on the horizontal plane. So now our duty is, our job is, so there are different types of solids are there. So we're going to list it out, and we're going to discuss the terminology, what we generally use it in our projection of solids. So later space we will going to show. So we will going to place these solids, and we will going to observe, and we will going to draw the printing in the top. That is what we call it as the projection of solids. So only the difference between the planes and the solids is, in the case of the planes, only the two dimensions were there. So you used to get the side, just like a pentagon of a 25 millimeter side we used to get, and the height we used to use the what we call it as the two dimension, that is the length and the width. But in the case of a solid, so apart from length and the width, we have an height also. The third dimension will be added to the projection. So if that is the case, how we can project the solids in our engineering practice? This is what we will go to discuss throughout the concept of projection of solids. Okay. So this is just an introduction to the projection of solids. So now comes the examination, the question. So in the question paper, in the examination, so you will have only one question on solids. Okay. so which carries 45 points. So there will be no internal choice for this projection of solids. So projection of solids is compulsory for everybody. So unlike just how we have lines and planes, we will have a choice, and even the module 5, module 5 and module 6 will have a, module 4 and module 5 will have a choice. So in module 3, so we don't have any choice over here. Okay, so all entire problem, it is a compulsory question for 45 minutes. So therefore, so utmost care should be given for this projection of solids. Okay, so because it looks simple, but some of the things you should be very careful while you are drawing the projection of solids. So hoping you are all understood the projection of planes, and I am just starting with the projection of solids. Okay. Yeah. Let us first discuss what is this projection, what is a solid. Okay, so what is a solid and what are the different types of solids, and with reference to each solid, we will going to discuss the terminology. Okay, then later onwards we will going to start understanding. So what is, how we can project these solids. Okay? Let us take the definition of a solid. So please, I request everybody to type your USN in the chat box once you enter, so that will be counted for your attendance. This is another one reminder for everybody. Okay, please type your USN in the chat box. Right. So now let us start understanding what is a solid and what are the different types of solids and how we classify the solids. A solid, when we start with this definition of a solid is a three-dimensional object having length, breadth, and thickness. It is completely bounded by a surface or surfaces which may be curved or a plane. So solid is a three-dimensional object. So that's what I was talking. So it is a three-dimensional object which has got length, breadth, and thickness. Okay. And it will have, it has been completely bounded by the surface, which might be in the form of a curved shape or it might be a plane. Okay. The shape of the solid is described by drawing its two orthographic views, usually on the two principal planes. One is HP and UP. So the shape of the solid, we describe it by just drawing the orthographic views. The solids may be divided into two main groups. One is called polyhedron. Second one is called solids of revolution. So there are n number of solids are there. So based upon their bounded surface, the solids may be classified or it has been categorized into two main groups. One is called polyhedron and second one is called solids of revolution. So what is polyhedron? A polyhedron is defined as a solid bounded by planes called faces, which meet in straight lines called edges. So poly means many, hedron means faces or surfaces, what you can say. If a solid which is bounded by the planes, bounded by many surfaces, poly means many, hedron means planes or surfaces or faces, whatever it might be. So when a solid which is consisting of planes which are bounded together, then it is said to be a polyhedron. In the sense, the surface which bounds or which forms the solid is a plane. So such type of solids, we call it as a polyhedron. Okay, so which meets in a straight line, the faces which meets in a straight line, just like how we discussed the pentagon or hexagon, what we say, the edges, the straight line, we call it as edges. There are 7 regular polyhedra which may be defined as stated below. So we have different types of polyhedrons there. One is a prism, second one is a pyramid, third one is a tetrahedron, fourth one is a cube or a hexahedron, fifth one is a octahedron, sixth one is a dodecahedron, and seventh one is icosahedron. So this is of the different types of polyhedrons, 7 regular polyhedrons. Of course, in our syllabus, we have only first 4: prism, pyramid, tetrahedron, cube, or hexahedron. So under the polyhedron, we have only 4 different regular polyhedra we need to discuss in our syllabus. One is a prism, second one is a pyramid, third one is a tetrahedron, and fourth one is a cube or hexahedron. So cube can also be expressed or can be called as a hexahedron. Please remember this, because in the problem sometimes they are going to give hexahedron or sometimes they are going to give cube. So all these 4 things we will go to discuss, and we will give concentration mainly on these 4. So because octahedron, dodecahedron, and icosahedron is not there in the syllabus, so it is not a part of our discussions in the projection of solid. Yeah. So these are some of the sketches what I am showing you over here. It is a polyhedron. So look at this cube, prism, and pyramid. Okay, just the pictures I am showing you over here. So these are all the solids. You can say polyhedrons means the solids which are bounded by the plane surfaces. It consists of many number of plane surfaces. We call it as the polyhedrons. So some of the polyhedrons what we discussed, what listed out is a cube, a prism, and a pyramid. So when you look at all these solids here, their surfaces is a plane. Look at this, a cube which is consisting of the square plane, the prism which is consisting of the lateral surfaces in the form of a rectangle, and of course base depends upon what type of geometry, whether it is a square based prism or a pentagonal based prism or hexagonal based prism or triangular based prism, whatever it might be. But the base is connected to their top face by means of a plane surfaces, what we call it as the faces. Okay. So similarly, pyramid. So when you look at the pyramid, it is a triangular surfaces. It consists of the surfaces which are bounded and which are in the form of a triangular faces. Okay. So where prism will have a rectangular faces, whereas pyramid will have a triangular faces. So these are all plane surfaces only. So that's why we call them as a polyhedron. Yeah, let us start with polyhedrons. Later part I will take you for solids of second type of category. A prism. It is a polyhedron having 2 equal and similar faces called its ends or bases, parallel to each other and joined by other faces which are rectangles. This is what the description of a prism. What is a prism? Basically, a prism is a polyhedron which has 2 equal and similar faces. In the sense, the top and the bottom we call it as, or in our words we call it as a base which is at the bottom, and the top. The 2 equal surfaces, top and the bottom of the prism, are equal and similar. Okay, and they are called ends or bases, and they are parallel to each other, and these are joined by other faces which we call it as a rectangle. In the sense, a prism which is having the top and the bottom, which are equal and similar, and they are parallel. They are parallel to each other, and each edge or the side of the top and the bottom is joined by the faces which are rectangles. So such polyhedra we call it as a prism. So 2 equal and similar faces might be in the form of a square. If the square is the top and the base, it is a square-based prism. If it is having a pentagon, it is called a pentagonal prism. If it is having a triangular shape, it is said to be triangular, and similarly hexagon. So when you look at the diagrams over here, this is called a square prism. So here, this is called the base. This is the base and this is the top face. Look at the top face and the base, both are square. They are equal and similar. Equal in size and they are similar in shape. Okay, look at this. And each face or each side of the top and the bottom is connected by or joined by a rectangular face. Rectangular face. So that's why it is called as square prism. In the similar way, you can see the triangular prism over here. So base is a triangle, okay, and they are parallel to each other. Base and the top are triangle and they are parallel to each other, and their edges are joined by the surfaces which are rectangles. So this is called the, what do you call it as, the triangular prism. In the similar way, we have a pentagonal prism, and similarly we have a hexagonal prism where the base and the face is in the form of a pentagon, and here it is in the form of a hexagon. Okay. So one important thing what you're supposed to understand in case of a solid is the axis. So till now we have not used the word axis in our projection of solids, projection of lines or points or planes. But when it comes for the solids, the axis is very important. So in each and every problem what you will going to draw, so it is mandatory for you to represent the axis. So what actually you mean by the axis? Basically, an axis is an imaginary line which connects the midpoint of the top face to the bottom face. An imaginary line which passes through, you can connect it, which passes through the midpoint of the top face and the bottom face, we call it as an axis of a solid. Okay, so this axis of a solid is to be represented in the case of a solid. Okay, so this is what we call it as the axis. What I am showing here, you can see the axis. Okay, so even in pentagonal prism, you can see the axis, and even in the hexagonal prism, you can see the axis. An imaginary line passing through the midpoint of the top face of the solid to the bottom face of the solid. So that line we call it as an axis. So axis is the very important representation in our solids. Okay, and this is what we call it as the edge of a solid. Edge. You can see the edges. So all edges are straight lines only in the case of a prism. Okay, and then this is the base edge. We call it as the edge of the base. We call it as the base edge. Okay, so this is also called as the lateral surfaces. This is what we call it as the rectangular faces or lateral surfaces. Anything you can use the word rectangular face or lateral faces or lateral surfaces. Okay, so this is what just a description of a prism. Why? Because these are the terms we generally use in our projection of solids. So we'll say the edge of a base or edge or rectangular face of a solid or a lateral surface of a solid, axis of a solid. Like that, we will keep on using those terms quite commonly when you are discussing the projection of solids. Okay, this is the description of a prism. The most important thing is top and the base are equal and similar, and they are parallel and they are joined by the rectangular face. And another important thing is the axis. This is very important in the case of any solid you can take. And the second polyhedra is a pyramid. Here, a polyhedra which is having a plane surface as a base and a number of triangular faces meeting at a common point called a vertex or apex. See here, the second type of polyhedron. So in this type of polyhedron, there is a one plane surface. There is a one plane surface which we call that as a base, and the remaining plane surfaces are all in the terms of a triangular faces. All these triangular faces emerging from the each edge of the base will meet at a common point is called vertex or an apex. So when you look at this diagram over here, this is the pyramid. Okay. So you can see the base. The base is a triangle over here. Okay. This is called a base. Okay. So from each edge of the base, there arises a triangular face. Okay. And all these three triangular faces will meet at a common point. Common point. That point we call it as a vertex or an apex of a pyramid. Okay. A vertex or an apex is the point at which the number of triangular faces arising from the edges of the base will meet. We call it as a vertex or an apex. Okay. So this is the triangular pyramid what we are shown. This is the base, and of course here also we are showing the axis, very important here, and this is called the lateral edge. This is called the lateral edge. This is very important. Lateral edge, and this triangle we call it as a lateral surface. This is the lateral surface. Surface is a triangle. Lateral surface is a triangle, and the edge of that triangle, lateral surface, is the lateral edge. Because these are all the things what we generally come across in the later stages. Okay. In a similar way, we have a square-based pyramid. See here, the base is in the form of a square. So of course, from each side you have a triangular surfaces and meeting at a common point. And similarly, we have a pentagonal pyramid, so where the base is a pentagon, and here we have a hexagonal base. Yeah. Next is solids of revolution. The remaining two, tetrahedron and the cube, I will discuss when I just start the problems in the when I start the problems on tetrahedron and hexahedron. Okay. Then the second type is solids of revolution. When a solid is generated by revolutions of a plane figure about a fixed line, then such solids are named as solids of revolution. When a solid is generated by revolutions of plane figure about a fixed line, then such type of solids we call it as the solids of revolution. Yeah. In this solids of revolution, there are these are the surfaces which are generated by plane figures. Means when the plane figure is being rotated about a fixed line, the axis, then the surface what it sweeps, we call it as the solids of revolution. Simple example, if we take a right angled triangle, and if a right angled triangle has been rotated about the fixed line, the surface which sweeps and the resulting solid is in the form of a cone. Okay, so right angle triangle is the plane figure which rotates about its fixed axis and it forms a surface or a solid, we call it as a cone. In the similar way, we have so many solids of revolutions. One is a cylinder, cone, sphere, ellipsoid, paraboloid, hyperboloid. There are plenty of solids of type we are having. But in our solids, we discuss only the cone. In the projection of solids, we discuss only the cone. But when we move to the isometric projection, so we need to add the cylinder and the sphere also. Okay. Of course, projection of solids, we don't discuss cylinder and sphere. Only the projection of cones will be there. So that is what the syllabus, what video syllabus says. Okay, so we'll have only the cone and remaining ellipsoid and paraboloid and hyperboloid. Of course, we just neglect it. It is not there in our syllabus. Okay, so only in projection of solid we have cone, and in the case of isometric projection, so apart from cone, we need to add cylinder and the sphere. So when I discuss isometric, the last module, I will go to discuss what is cylinder and sphere, how to form. These are all some of the solids of revolutions you can see. This is a cone, this is a cylinder, and this is a sphere. Okay. Yeah, let us just have what is a cylinder? A right circular cylinder is a solid generated by the revolution of a rectangle about one of its axes. So when you take a rectangle, okay, and when you sweep the rectangle or when you rotate the rectangle about its one of its edges, keeping one of the edges fixed, and when you rotate the other end and what it sweeps, the revolution, what it generates is a cylinder. Okay, it has two circular bases. So top and the bottom, it is equal circular bases. The line joining the centers of the back is called an axis, and it is perpendicular to the. Please always remember, these axes are always been perpendicular to the base. Okay, this is very important. Okay. Next comes cone. A right circular cone is a solid generated by the revolution of right angle triangles about one of its perpendicular sides, which is this. What I was talking. A right angle triangle, when their axis is been fixed and it is been rotated, or when it's one of the edge is been fixed and it is been rotated, then it will forms a solid of revolution, what we call it as a cone. Okay. So this is the cone, and of course I will discuss because we will have to discuss cones in our solids projection of solids. I will discuss some of the things here. So the topmost we call it as an apex, and this circle we call it as a base. Okay, and the surface, the of course when you draw a orthographic or a two-dimensional, so we have to represent it in this way. So these lines we call it as generators or end generators. Anything you can call it as end generators. So these two end generators or end generators will meet at a point, we call it as an apex. This is the solids of revolution. It just does not have any edges or sides. It is just like a curved shape, and the peak or the topmost point, we call it as an apex of the solid. Okay. So of course, the base is always been a circle in the case of a cone. Okay, and the imaginary line which joins the apex to the midpoint of the base or center point of the base, we call it as the axis of the cone. So this axis is perpendicular to the base. So please remember, this is very important for us. Okay. So this is just an introduction to the different types of solids. So what is a solid and what are the different categories of solids, polyhedron solids of revolution. Under polyhedra, so what are the different types we are having, okay, and their basic terminologies. And of course, under the solids of revolution, so what are the solids we need to discuss, and what is the terminology in the solid discipline. So this is just I wanted to give an introduction to the solids. The most important thing, the one important addition to the solids is the third dimension, one important thing. And the second important thing is the axis, representation of the axis. So you have to present the axis without pain. It is very, very, very important for the students to represent the axis in the projection because it carries marks. If you are not shown the axis in the solids, you may lose 3 to 4 marks. Okay, out of 45, even everything is right, and if you are not represented axis, so definitely minimum 3 to 4 marks you may lose. So therefore, be careful. So don't forget to represent the axis in the projection of solids. Okay. Now, these are the different types of solids what I am talking about. So next comes is how to draw the projection of these solids. Means when these solids have been placed in a different positions, or it has been placed in a different positions or different orientations with respect to the our reference planes VP and HP, and how to draw the projection. That is how to draw its top and front views. Of course, you can place the solids in a different positions with respect to the VP and HP. So as we discussed in the case of a planes, the plane resting on HP, plane resting on VP, okay, resting with the edge on HP, resting with the corner on HP, and similarly in the case of VP also. But in our syllabus, please remember, in our syllabus, the projection of solids has to be carried out only by keeping the solids in the horizontal plane only. Okay, only in the horizontal plane. So nothing to do with the vertical. Means we are not keeping the solids in the vertical plane. So we are base position is you are keeping the solids on the horizontal plane, and you will go into position these solids with respect to the VP and HP in a different way, and then we will go into represent or we will go into project. Please remember, the solids should be kept only on the horizontal plane. Okay, so we don't have the solid should be kept in the vertical plane. Okay, so those problems are not there in our syllabus. Because the concept is there, but we don't have those concepts to be discussed in our syllabus. So please remember that. So we are solving the problem only by keeping the solid or the base of the solid on horizontal plane only, HP only. Okay, so when you keep it on HP, and we will go into represent what is its front view and what is its top view with respect when it is in position in the different ways with respect to the VP and HP. Okay, this is a very important thing you're supposed to remember. Be careful. Okay. Yeah. So just I'm just telling you, we are keeping the solids on the horizontal plane, and we are getting the different positions. Okay. Now let us just go back to the next one. Yeah. Projection of solids in simple positions. A solid in simple position may have its axis perpendicular to one of the reference plane or parallel to, in the sense, the solids might be placed, that's what I was talking, the solids might be placed with different positions. So that is, a solid in simple position may have its axis perpendicular to one reference plane or parallel to. So means we can have the axis perpendicular to HP and perpendicular to VP. But we are in our syllabus, we are talking only the axis perpendicular to HP only. Axis perpendicular to HP. When the axis is perpendicular to one of the reference plane, it is parallel to the other. Okay, so please remember, throughout our projection of solids, we are keeping the solid on the horizontal plane. Means we are keeping in such a way that base is resting on HP and the axis is perpendicular to HP. Once it is perpendicular to HP, means default it is parallel to VP. Okay. So when the solid is perpendicular or when the axis of a solid is perpendicular to HP, and definitely it is parallel to VP. So this is the one important thing you're supposed to remember. Okay. We have already seen that when a plane is parallel to a reference plane, its projection plane shows the true shape and true size. So that is, so when you position a solid with respect to horizontal plane or vertical plane, its true shape can be seen only when it is been parallel to it. Okay, when the line is parallel to HP, okay, its true shape can be seen in the HP. When the plane is parallel to HP, its true shape can be seen in HP. When the plane is parallel to VP, the true shape can be seen in the VP. So this is a very common statement we keep on using from the projection of lines. So when the object is parallel to the respective plane. So the true shape and true shape, true size can be obtained on the particular plane only. So this is the thing what they are talking about. Therefore, the projection of a solid on a plane to which the axis is perpendicular will show the true shape and size of its base. Please remember this. Please remember this. It's very, very, very important. The projection of a solid on the plane to which the axis is perpendicular will show the true shape and true size of its base. So since we are keeping the solid on the base on HP, and that base will be parallel to HP. Okay, so therefore, the true shape and true size of the base of a solid, either it might be a square based, or it may be a pentagonal based, or it might be a hexagonal based. The true shape of a square or a pentagon or a hexagon can be seen in the horizontal plane or in the top view. Okay, hence when the axis is perpendicular to the ground, that is to the HP, the top view should be drawn first and the front view projected from it. So this is a very important statement to be remembered. When the axis is perpendicular to the ground or HP, ground means HP we are talking about. When the axis is perpendicular to the ground, so this is the position what we are talking throughout the projection of solids. Please remember, the axis is perpendicular to HP. Okay, that is the common initial position in our projection of solids. Okay, the top view should be drawn first. So first we are going to draw the top view. So means necessarily it is a base we are showing. The base, the true shape and true size of the solid, which is in the form of a base, we are going to show. And from that base or from that top view, we will going to project the front view. This is the basic procedure what we will going to employ in the projection of solids. Okay, and the next two things I don't want to discuss here because it is out of our syllabus. Okay, yeah. So one simple I will explain here. So how it will going to get when the axis is perpendicular to HP. Draw the projections of a triangular prism base. Okay, I don't want to discuss all these things. First, I am going to take you to this diagram. See what is doing, what we are discussing here is my dear students, are you following? Any clarification, any doubts, you can stop me at any position, at any point. Are you following? Anything to discuss, my dear students? Anything to discuss anywhere, you can stop me and you can ask me. I want everybody to type your USN in the chat box, name and USN in the chat box. That will be counted for your attendance. Please be careful. Okay, type your USN and the name in the chat box. Yeah. So now I was talking about the solids. So look at here. It is a triangular prism. It is a triangular prism. Okay. And this is the general position of a triangular prism over here. Okay. So it is being kept on the this is the horizontal plane and this is the vertical plane. Okay. Horizontal plane and vertical plane. And our common position of a solid is being kept over the horizontal plane. So across the horizontal plane, either you can rest it on the edge or rest it on the corner. Anyone you can do that. I will discuss that cases later, right? So here, the solid, the triangular prism has been placed over the horizontal plane. Okay, so its axis will be perpendicular to HP. Okay, axis is the imaginary line which passes through the midpoint of the top face to the midpoint of the bottom face. So that is the axis is perpendicular to HP. When the axis is perpendicular to HP, it should be parallel to VP. Am I right? So it is just like a vertical line. Vertical line is just the line perpendicular to HP and parallel to VP. So now look at here. So in this case, so when you observe from the top for top view, you can see the top face. This face is visible to us. So that is A, B, and C. This shape of a triangle, it is true shape and true size can be seen in the top view. And this top face, top triangular face, it is equal and similar and also parallel to the base of the solid. So base is here D, E, F. D, E, F, A, B, C. They are equal and similar, okay, and they are parallel. So when you are observing from the top, you can see the edges AB, BC, and AC. These triangular edges or triangle face can be seen in the top, but the bottom triangle face D, E, F is not seen. Okay, because I will tell you the rules of visibility later. So you can see, and these two are parallel, but only you can see this triangular face and this triangular face DEF is not visible because A coincides with D, point B coincides with E, and C coincides with C. Just like it is a triangular face we can see in the top view, which is true shape and true size. I think you can see this is the top view where we are going to start with the top view. You can see here, top view we have drawn. This is a triangle A, B, and C. And of course, at the bottom, there is another one triangular face, which is the base, which is D, E, and F. So this is what you can see in the top view. In the similar position, when you see from the front, in the front, you can see the triangular face A, C, F, D. This triangular face is visible and remaining two triangular faces are not visible in the front view. As you see from the front, so it is a rectangular face. The rectangular face which joins the top face edge AC to the bottom base edge DF. Okay, so only you can see the rectangular face or a rectangle is the front view, whereas the two remaining rectangular faces in this case are not visible. Okay, so therefore the front view will be a triangle. You can see the triangle has been shown in the front view or projected over here. Okay, so just drawing the projectors back to the planes which are perpendicular to the visual face. So this is the orthographic view what we have shown. It is a rectangle face. So this is how we will go into start. This is what we call it as initial position. So why I am talking this is, so when you want to start a projection of solids, the initial position is very important. So in the initial position, so true shape and true size of the base and the face can be seen in the top view, and hence you have to start with the top view. Always we have to start with the top view in the solid. Please remember, you have to start with the top view where you will going to represent the true shape and true size of the base and the face. Okay, from the top view you will go into project it for the front view. This is called the height of the prism or the axis length. Axis length and the height of the prism will remain same. Don't get confused. Axis length and the height of the prism are same. Okay, this is how we will go into represent. See, this is, I hope you people are understanding. Just only I just conclude for a while, just another 2 minutes. Afterwards, I will give 5 minutes and we'll go to start later. Okay. So this is the different solids resting on HP. So with the base edge. So first I take it as a base edge. So in this case, especially in the case of a solid resting on HP with the edge, so edge should come to your right. So please remember this. You look at this edges, square based, pentagonal based, and hexagonal based. So in all these three cases, the edges are to your right. So it is just totally reverse of the planes what we discussed. Okay, in the case of the planes, it was I asked you to do it on the left side. Either it is a corner or edge. But here, in the case of a solid, it should be always to your right. So therefore, you should be very careful over here. So of course, in hexagon, it is not a problem. But when it comes for the pentagon, so here you will have an opposite edge and the opposite corner. So edge should be your right. Okay, this is the initial position of the solid resting on HP with a base edge. And second one with a base corner. Solid resting on the HP with base corner. So this is the one what we want to have. The corner resting. So look at here. The pentagon, the corner has come to your right. Okay. So this is the hexagon. So this is the initial position of the solids resting on HP. This we have to start. I wanted to start, or we have to begin with the solids of the projection of solids with this diagram. Yeah, so I was talking about especially another most important thing in the case of a solids is the rules of visibility. So why? Because the solids are not like a planes. Planes are two-dimensional, whereas solids are three-dimensional. When you position a solid in such a way that it has been inclined to HP or VP with different inclinations, so and observing that object either from the front or from the top, you may not see the edges and the corners. Some of the edges might not be seen, some of the edges or some of the corners may not be seen in the respective positions or respective directions. So therefore, it is mandatory in the case of a solid to show or to represent the visible and invisible edges. Visible and invisible edges, both you have to show. So which are seen and which are not seen. So this is very important. It is a very challenging, it's just quite interesting task because it involves a lot of imagination for you people. Okay, so therefore, so you should be in a position to know which side is visible and which corner is visible, which is not visible. So those things you have to imagine, and correspondingly you have to represent visibility. Okay, so therefore, so small rules they have specified. Okay, we will go to discuss that rules within just one or 2 minutes, and I will just give a time for you to have a break. Okay, so the rules of visibility here is, please look at here, either in front view or top view, the edges or corners nearer to the observer to be considered as visible and away from the observer as invisible. Okay, I will tell you these things. Please, I will explain these things clearly when I just show the projection of a solid. So please remember this, either in front or top. Okay, observing from the front or from the top side, the edges which are nearer to the observer, the edge which is nearer to the observer are considered as visible. Please make a note of this, everybody. Nearer to the observer are visible, away from the observer are invisible. That's why I have put it in the different colors. Nearer, visible, away, invisible. So these two important words you have to remember. Okay, that is either in the top or in the front view. Anything it will be full scope. That is a one important. Second important rule what you're supposed to follow, either in front view or top view, the outlines of the solid should be considered as visible only, irrespective whether it is visible or invisible. See, when you draw a projection, either the front view or a top view, so you will have an outline of a solid. Okay, this also I will discuss in detail when I just start. Outline of a solid. So these outlines might be visible or it might be not visible either in the front or a top, irrespective of their visibility in the front or a top view. But these outlines of the solid should be considered as visible only. Whether it is visible or invisible, the outlines of the solid should be represented as visible lines. These are the two important rules of visibility you're supposed to remember. Okay, so either in the front or at top, the edges which are nearer to the observer are visible, which are away from the observer are invisible. This is very important. Nearer, visible, away, invisible. And second important thing is the outlines. the outlines of the solid, whether it is visible or invisible, should be considered as a visible only. Okay, of course, in both top and front views. So quickly, so how to represent the visible line? Thick continuous line. Thick continuous line is the representation of a visible line. Invisible line, thick dashed line. You look at here, the representation I think you can see in the slide. So thick visible and thick invisible lines here. Okay, so this is just an introduction to our okay, so just an introduction. So I will just stop at this point for a while. I will give 5 minutes break for everybody. So I want you people to reach on. So it is 9:31. I want you to, by 9:36, I want everybody to be joined here, and we will go into start this. If you have any clarification at the first 5 minutes, we will go into discuss this, and later onwards we will go into proceed. Okay. So please have a 5 minutes break, and I will come back again, and we will go into